for resistors placed on a three-phase circuit without specifying the type of resistor, it is impossible to determine the voltage after the resistor. The voltage across a resistor depends on its resistance value and the current flowing through it. The minimum voltage for a lighting transformer switch is typically around 12 volts. This is because lighting transformers require a low voltage to safely operate. However, the specific voltage may vary depending on the type of transformer and application. Questions like these are not commonly found in standard test prep books. They may be more specific to certain industry certifications, specialized training programs, or local electrical codes. To prepare for these types of questions, consider the following resources. Firstly, industry-specific certification manuals. These manuals may cover specialized topics that are not included in general journeyman electrician test preparation materials. Secondly, local electrical codes. Local codes may specify minimum voltage requirements for lighting transformer switches or other specific equipment. Thirdly, online forums and industry discussion groups. You can engage with other electricians and industry professionals to ask questions about specific topics. Fourthly, specialized training courses. Some organizations may offer training courses that cover advanced electrical concepts. Considering electrical circuits, understanding how resistors behave in both direct current and alternating current scenarios is fundamental. In a direct current, or DC, circuit, a resistor simply impedes the flow of current. The relationship between voltage, current, and resistance is defined by Ohm's law, which states that voltage equals current multiplied by resistance, or volts equals amps times ohms. Therefore, if you know the resistance and the current, you can easily calculate the voltage drop across the resistor. However, in an alternating current, or AC, circuit, the situation becomes more complex. While Ohm's law still applies instantaneously, the voltage and current are constantly changing, typically in a sinusoidal manner. Furthermore, in AC circuits, you have to consider not only resistance but also impedance. Impedance is the total opposition to current flow and includes both resistance and reactance. Reactance comes from components like inductors and capacitors, which store energy and release it back into the circuit, causing a phase shift between the voltage and current. In a three-phase system, things get even more intricate. A three-phase system consists of three AC voltages that are offset from each other by 120 degrees. This configuration provides several advantages over a single-phase system, including smoother power delivery and higher power capacity. When you introduce a resistor into a three-phase circuit, the effect depends on how the resistor is connected. For example, it could be connected in a delta configuration, where each resistor is placed between two of the phases, or in a Y configuration, where each resistor is connected from a phase to a neutral point. The voltage across each resistor and the current through it will depend on the specific configuration and the values of the resistors. Without knowing the specifics, it's impossible to determine the voltage after the resistor. Regarding lighting transformer switches and their minimum voltage requirements, safety is the paramount concern. Lighting transformers are used to step down voltage, typically from a higher voltage like 120 volts or 277 volts to a lower voltage such as 12 volts or 24 volts. This lower voltage is much safer for operating lighting fixtures, especially in environments where there's a risk of electric shock, such as swimming pools or wet locations. The National Electrical Code, or NEC, provides detailed guidelines for electrical installations, including requirements for transformers and lighting systems. The NEC specifies minimum clearances, grounding requirements, and overcurrent protection to ensure safety. The minimum voltage for a lighting transformer switch is related to the design and application of the lighting system. Typically, these systems operate at low voltages, often 12 volts or 24 volts, to minimize the risk of electric shock. The switch itself must be rated for the appropriate voltage and current. When selecting a lighting transformer and switch, it's crucial to consider the total load of the lighting fixtures. The transformer must have sufficient capacity to handle the load without overheating or becoming overloaded. Overloading a transformer can lead to premature failure and potentially create a fire hazard. Furthermore, the switch must be rated to handle the inrush current of the lighting fixtures. Inrush current is the momentary surge of current that occurs when the lights are first turned on. It can be significantly higher than the steady-state current, and if the switch is not rated to handle it, it can damage the switch contacts. To stay up to date with the latest electrical codes and industry practices, consider the following resources. Firstly, the National Electrical Code. The NEC is the most widely adopted electrical code in the United States. It's updated every 3 years and provides comprehensive guidelines for electrical installations. Secondly, industry-specific certification manuals. Organizations like the National Fire Protection Association, or NFPA, and the International Association of Electrical Inspectors, or IE, offer certification programs for electricians and electrical inspectors. These programs often include manuals and training materials that cover specialized topics. Thirdly, online forums and industry discussion groups. Websites like Electrical Contractor Magazine and My Cult Enterprises offer forums and discussion groups where electricians can ask questions, share knowledge, and stay informed about industry trends. Fourthly, specialized training courses. Many community colleges, technical schools, and trade unions offer training courses for electricians. These courses can cover a wide range of topics, from basic electrical theory to advanced motor controls and programmable logic controllers, or PLCs. Understanding the nuances of three-phase systems and lighting transformers requires a combination of theoretical knowledge and practical experience. By staying informed about the latest codes, participating in industry discussions, and pursuing ongoing training, you can enhance your skills and knowledge as an electrician. Furthermore, when working with electrical equipment, always prioritize safety. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. To energize circuits before working on them, and use lockout-tagout procedures to prevent accidental energization. Electrical work can be dangerous, but by following safe work practices and staying informed, you can minimize the risks and ensure a safe working environment. When dealing with resistors and three-phase circuits, it is crucial to understand the different configurations and their implications. As mentioned earlier, the two most common configurations are delta and Y. In a delta configuration, the resistors are connected in a closed loop, with each resistor connected between two phases. This configuration is often used in applications where a balanced load is desired. A balanced load means that each phase carries the same amount of current. In a Y configuration, the resistors are connected from each phase to a common neutral point. This configuration is often used in applications where a neutral connection is required. A neutral connection provides a return path for unbalanced currents. When analyzing a three-phase circuit with resistors, it's essential to use appropriate circuit analysis techniques. These techniques include Ohm's law, Kirchhoff's laws, and the superposition theorem. Ohm's law, as mentioned earlier, relates voltage, current, and resistance. Kirchhoff's laws state that the sum of the voltages around a closed loop is zero, and the sum of the currents entering a node is zero. The superposition theorem allows you to analyze a circuit with multiple sources by considering the effect of each source individually and then summing the results. In addition to these basic circuit analysis techniques, it's also helpful to use circuit simulation software. Circuit simulation software allows you to model a circuit and simulate its behavior. This can be a valuable tool for verifying your calculations and identifying potential problems. Regarding lighting transformers, it's important to understand the different types of transformers and their characteristics. There are two main types of transformers: iron core transformers and electronic transformers. Iron core transformers use a core made of laminated iron to increase the magnetic flux and improve efficiency. Electronic transformers use electronic components to switch the voltage at a high frequency. Iron core transformers are typically used for larger loads and higher power applications. Electronic transformers are typically used for smaller loads and lower power applications. When selecting a lighting transformer, it's crucial to consider the input voltage, output voltage, and power rating. The input voltage must match the voltage of the source power supply. The output voltage must match the voltage requirements of the lighting fixtures. The power rating must be sufficient to handle the total load of the lighting fixtures. In addition to these basic considerations, it's also important to consider the transformer's efficiency, regulation, and harmonic distortion. Efficiency is the ratio of output power to input power. Regulation is the change in output voltage from no load to full load. Harmonic distortion is the presence of unwanted harmonics in the output voltage. A transformer with high efficiency, good regulation, and low harmonic distortion is generally preferred. When installing a lighting transformer, it's important to follow the manufacturer's instructions and all applicable electrical codes. The transformer must be properly grounded and protected from overcurrent. The wiring must be sized appropriately for the load. The transformer must be located in a well-ventilated area to prevent overheating. Furthermore, it's important to perform regular maintenance on lighting transformers. This includes inspecting the transformer for damage, cleaning the transformer to remove dust and debris, and tightening any loose connections. Regular maintenance can help to extend the life of the transformer and prevent problems. When troubleshooting electrical circuits, it's important to have a systematic approach. Start by identifying the symptoms of the problem. Then use a multimeter to measure voltages, currents, and resistances. Compare your measurements to the expected values to identify the source of the problem. Once you've identified the source of the problem, take steps to correct it. This may involve replacing a faulty component, repairing a broken wire, or tightening a loose connection. When working with electrical circuits, always be aware of the potential hazards. Electricity can be dangerous, and it's important to take precautions to protect yourself. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. De-energize circuits before working on them and use lockout-tagout procedures to prevent accidental energization. If you're not comfortable working with electricity, it's best to call a qualified electrician. In summary, understanding resistors and three-phase circuits and lighting transformers requires a solid foundation in electrical theory, practical experience, and a commitment to safety. By staying informed about the latest codes, participating in industry discussions, and pursuing ongoing training, you can enhance your skills and knowledge as an electrician and provide safe and reliable electrical services. Remember that continuous learning and staying updated with the latest advancements in electrical technology are crucial for success in the field. The electrical industry is constantly evolving, with new technologies and techniques being developed all the time. By staying up to date, you can ensure that you're providing the best possible service to your clients and that you're working safely and efficiently. The importance of understanding local electrical codes cannot be overstated. Local codes may vary from the National Electrical Code, and it's essential to be familiar with the specific requirements in your area. Local codes may address specific issues related to the environment, climate, or local infrastructure. Ignoring local codes can lead to violations, fines, and even legal repercussions. In addition to understanding the technical aspects of electrical work, it's also important to develop strong communication skills. As an electrician, you'll need to communicate effectively with clients, contractors, and other professionals. This includes being able to explain technical concepts in a clear and concise manner, listening attentively to others, and resolving conflicts constructively. Strong communication skills can help you build trust, establish rapport, and ensure that projects are completed successfully. Finally, remember that being an electrician is not just a job, it's a profession. As a professional, you have a responsibility to uphold the highest standards of ethics, integrity, and professionalism. This includes being honest and fair in your dealings with others, respecting the confidentiality of your clients, and continuously striving to improve your skills and knowledge. By embracing these values, you can build a successful and rewarding career as an electrician.